Welcome to Learn Earth Together. Today we'll discover how our planet, Earth, was formed billions of years ago. Today we will examine how our planet, Earth, was formed billions of years ago. About 4.6 billion years ago, in one corner of the Milky Way galaxy, there existed a giant cloud of gas and dust called the Solar Nebula. This cloud is called the Solar Nebula. Over time, this cloud began to collapse under its own gravity. During the collapse, the cloud rotated and compressed, forming a large mass at the center. This mass later formed the Sun. Small particles orbiting the Sun collided and coalesced over time. These collisions formed first small rocks and fragments, and then larger celestial bodies. This process is called planet formation. Scientists believe this period lasted hundreds of millions of years. During this time, countless meteors came together to form the building blocks of new worlds. In fact, the number and positions of today's planets weren't fully established at the time. Many objects collided and shattered, and some were swallowed by the Sun. Closer to the Sun, temperatures were high, leading to the formation of rocky planets like Mercury, Venus, Earth, and Mars. Farther out, temperatures were lower, and ice and gases coalesced to form giant planets like Jupiter and Saturn. The Earth's story began as part of this formation, young and formless, but slowly beginning its own journey. About 4.5 billion years ago, Earth resembled a giant fireball. Its surface was covered in molten rock, and temperatures were so high that there was no solid landmass. Earth was constantly under the impact of meteors and comets. Each impact further heated and shaped the planet's surface. This continued for millions of years. These collisions not only shaped Earth, but also enriched the planet's chemical makeup. Minerals and ice fragments carried by meteorites later became the source of the elements necessary for life. In other words, the fundamental materials necessary for Earth to host life in the future were carried by these visitors from deep space. Over time, Earth's exterior began to cool. This cooling led to the solidification of molten rock, forming the protocrust. However, the planet's interior remained dynamic, its surface constantly changing with lava flows, volcanic eruptions, and intense seismic activity. There was no ocean or atmosphere yet. Earth was shrouded in red, a blazing inferno in the void of space. But these harsh conditions were a necessary step in our planet's transformation into its current form. As Earth was forming, a monumental event occurred that changed the planet's fate. Approximately 4.4 billion years ago, a Mars-sized celestial body collided with Earth. Scientists named this object Theia. The impact was so powerful that huge chunks of Earth's surface were hurled into space. Over time, these fragments coalesced into a massive mass. This mass formed our satellite, the Moon, today. Scientists confirmed this theory by examining rocks found on the Moon's surface. The chemical makeup of the Moon rocks brought back to Earth by the Apollo missions bears strong similarities to the Earth's crust, strongly suggesting that the Moon is actually composed of material eroded from Earth. The Moon's formation not only added a new object to the sky, it also slowed Earth's rotation, offset its axial tilt, and caused tides. Tides, on the other hand, contributed to the emergence of life by regulating the movement of the oceans for billions of years. So the Moon is not just a beautiful light we see in our sky, but also a companion that plays a critical role in Earth's evolution. As the Earth's surface slowly cooled, volcanoes continuously spewed lava and gas. These gases consisted largely of water vapor, carbon dioxide, methane, and nitrogen. These gases formed Earth's early atmosphere. However, this atmosphere was not as suitable for life as it is today. It was filled with poisonous and dense gases. Over time, the water vapor condensed, triggering torrential rains that lasted millions of years. These rains filled the Earth's craters and gave rise to the first oceans. These were vast bodies of water that moderated the planet's temperature and would eventually harbor the first seeds of life. Scientists believe that meteoroids falling during this early period may have also brought significant amounts of water to Earth. Ice-covered comets and asteroids in particular may have collided with the young Earth and contributed to the formation of oceans. In other words, the source of the water wasn't just vapor from Earth's interior, but also visitors from deep space. At the same time, the formation of the atmosphere began to protect the Earth from harmful space radiation. The foundations for a suitable environment for life to flourish were now laid on our planet. The atmosphere and oceans played two crucial roles in shaping the Earth into its current form. After the oceans formed, Earth gradually began preparing the necessary environment for life. About 3.8 billion years ago, deep in the oceans, simple organic molecules combined to form more complex structures. Under these conditions, the first single-celled organisms emerge. These simple microscopic creatures marked a revolutionary beginning in the planet's history as they multiplied and evolved into more complex organisms over time. Traces of these early life forms can be found today in the world's oldest rocks and fossilized microscopic structures. For example, the 3.5 billion-year-old stromatolites discovered in Australia are structures formed by cyanobacteria that lived during this period. These fossils are among the most important evidence proving the longevity of life on Earth. About 2.5 billion years ago, some bacteria began photosynthesizing. This process led to the accumulation of oxygen in the atmosphere. This increased oxygen level laid the groundwork for the future development of multicellular organisms. This is the story of the birth of the Earth. Don't forget to subscribe to continue exploring our planet.